So in this video I'm going to make this PCB, which I've had made by PCBWay. They're one of my sponsors, so thank much PCBWay for supplying these at no cost. Make sure you go and check out the links down below to go and check out PCBWay, and if you need to get PCB made, then maybe go there and check them out. PCBWay also offer lots of services. They don't just do PCBs anymore, they just do other things too. They do 3D printing, CNC machining, even do PCB assembly, flat flexes and all that sort of stuff. I haven't tried the other services yet, but one day I will. Let's check out this board. So this board is pretty small. I intended it to be that way. I could have made it smaller probably, but this is small enough. I haven't even prototyped this board, like the actual circuitry. I've not prototyped it. I don't even know if it's going to work. We'll find out. It should be an interesting experience. We'll get to the end of it and find out whether the thing even functions. I think it will. Don't know yet. So what is it, you ask? Well, it's a constant current source. The idea is you attach a power supply to this thing and it will have a current output which passes through it, and that current output will generate a fixed current. It won't be adjustable, it's a fixed current. We'll have trimming, so this is what this adjustment here is for, to trimming, to trim the value to be exact. In theory, it should work. Everything's labelled on the board, so all the parts are there. You don't actually need a diagram, you can just put the parts in as per the diagram on here. And it'll work. Well, I hope it'll work. Like I said, I haven't even tried this out yet. I just sat down, quickly drew up a circuit, had PCBs made, and thought, right, I hope it works. We'll find out at the end. We'll find out once we build it. So PCBWay have actually upgraded me. So I actually had just a yellow solder mask, which is one of the colours I often use, and just plain hassle finishing on it. And they said, oh, we make it black and gold for you, make it look nicer. So they've done black and gold. It looks alright, doesn't it? Didn't need gold in this situation, but still nice to have. Now quite often when you order PCBs, you might actually get one or two boards extra because that's the way they laid out the panel and that sort of stuff. And they do actually make extra boards in case there's any electrical errors or testing failures and that sort of stuff. They do actually make some extra ones. In this case, I ordered 10 and I've got 15. So let's just describe the basic principles of what this board's supposed to do if it works. The idea is basically you have a transistor, which is in this case is an NPN transistor, and that goes through a resistor to your ground. That's the basic principle, and this is where you have your current source, right? So that's your output to your current source. And yes, I have awful handwriting. Okay, so that's the output to your current source like that. And here you have some kind of control signal, and here you have a sensor. So what we actually have here, which makes you wonder if it's even going to work, is I've got a, it's kind of like this anyway, I've got a TL431 voltage reference here, which is 2.5 volt reference, and I'm using a 25 ohm effectively resistor here. And what that'll do, you've got 2.5 volts at this point here, of course 25 ohms, so that should give you, so it's 2.5 volts over 25 ohms, that equals 100 milliamps. So in theory this thing should give you a 100 milliamps constant current source. The other thing you could do with this is actually change this resistor. If you change that resistor value, you can get a different current. So if you say made that 50 ohms instead, that would give you 50 milliamps. Now obviously this is only part of the circuit. The other part is you have a positive supply, alright? So that's your effective negative. Positive supply comes in, and that then is your current system, alright? So it goes through there, whatever your devices and whatever is through this system here. So your current is going through here to your positive supply rail, and your negative supply rail is then obviously coming in and going to your ground to complete the circuit. That is it. It might work, it might not. So I've explained the topology of it and what it is. I should actually explain how it works. So when you're passing a current through this transistor here, that current has to pass through to your ground through this path. Now as you may know from Ohm's law, which is mentioned on the back of one of these, VIR, and I've done a video about that as well, Ohm's law stuff, in the beginner's series. Put voltage across a resistor, you get a current. So that current will depend on what the resistor value is and what that voltage is. Now because we are using a voltage reference here to control this transistor, this should keep this point here at 2.5 volts. So this will change whatever it needs to do on this point. This is obviously simplified, it actually has a pull-up voltage and stuff as well going on, but I've left that bit out. This will try and keep this transistor biased in a way to keep 2.5 volts at this point. So this bit here is always going to be at 2.5 volts. That's the theory. That means that 2.5 volts over 25 ohms is 100 milliamps. That's it, and that's what will generate through this path. It's a simple theory. Let's hope I'm right. Let's build it and find out. Right, so I've got the parts together, kind of. I don't actually have the right resistors for this, so I'm having to adapt to it slightly. So I did want to have 51 ohm resistors in these two positions here, and I did actually have a 1k pot planned for here, which I've got, which would take it really close. It might actually be, I need 1.5k or 2k even maybe to be better, but that's what I planned. Even 56 ohm would have been better. The closest I've got, which is going to be a decent size resistor as well, is 67, which is also what I'm going to use over here for this resistor here, which means I can run off a 4 volt power supply. The idea is to be able to run this off an 18650 battery. That's the plan. In theory it'll work. We'll find out. I might play with voltages and see what actually works, but that's the plan. I've got ceramic caps here which aren't quite the right lead spacing. I've got the lead spacing slightly wrong here, so it'll fit. It's fine. It's just not be quite right. Yeah, I would have liked to have better resistors for this, but it is what it is. So it should be pretty straightforward to actually put it all together. So I'm just going to shove it all in. It won't take long. I've actually got slots in the board, as you can see. That's there for extra cooling, because I'm trying to avoid being too much heat around the TL431, because I don't know if it's in the reading. I'm trying to get better stability, so I've got these slots here for extra efficiency to try and break the heat. I could have done things like pulled the copper back and that sort of stuff. I didn't do that. I thought putting some slots in here will just be better. I'm also going to stand these resistors off the board slightly, because these will potentially be getting a bit of current going through them, so I'm going to stand them off slightly as well, just to not touching the board, just to give them a bit more heat dissipation. So these are half watt resistors. I mean, in theory a quarter watt would actually be good enough, because they're in parallel. 2 quarter watt resistors would be fine, no issue there. I'm not worried about that aspect of it. Oh, this is no good. Look, you see what I've done there? Look, one was back to front. I can't leave with that. So to get them off the board, I can see I'll just use a tweezer end here just to separate them off the board a little bit to keep them consistent height. This for tidiness, and then I can solder those on. Right, solder these in. I can move on to the next stage. Do you know what I forgot to do? I forgot to clean the board first. I might do that before I do the rest of the parts. It's always a good idea to put a little bit of IPA on the board and just give it a bit of a clean up, even if they're brand new like this. There you go. I put the heat up on my iron a little bit more to try and help the flux to work. That seems to have done the job. Yeah, it's better. I broke my other cutters, and it seems these ones aren't as good. Blades aren't lining up so well. It's a shame. Anyway, maybe I'll get better with use. Let's clean up with IPA and get it soldering a bit better. Right, that's the board cleaned up. Let's put some more parts on. I think I might put in the BD139 next. It actually has a hole to bolt it down. That may or may not be needed, depends on how hot it gets. I probably will bolt it down just to make sure, but I also need to make sure that what I do here is that that hole will line up. Here's the soldering iron bit, which happens to fit perfectly. Perfect. Let's solder it in. And if you're really worried about trying to get decent solder joints, use flux. This solder I'm using now is actually a silver solder. It's quite a nice high quality solder, and it doesn't have as much flux in it as some of my other solders do. So if I was really worried about it, I'd use my other one, which has got better flux in it. Just harsher, but it's also harder to clean off the board. But for this time I'm just going to use this one. Now I've cleaned up with IPA, it's going a lot better. So obviously must be the residue on the board or something. Let's do it from this side as well. Just want to make sure it's well soldered, because all that current is going through this. So this is still the TL431. Now I've got a choice. I'll either put it right down on the board to keep it nice and tidy and short, or I can lift it away a little bit. I'm actually tempted to lift it away a little bit just to help with the heat, but then it might end up actually being more of a problem. It's still got a bit of a gap there. It's not pushed right down, so I think that'll do. Well, I should actually be using a board holder for this actually. I do actually have a board holder, but I'm being lazy not getting it out. Let's put a bit of residence time on there to give a chance for the heat to soak through the board, and try and get the solder to flow through to the other side as well. Yeah, that's all good. Done. This board is actually going to be part of a bigger project I'm planning on doing, but I have to get this bit done first and see if this actually works. It better work. It may not. But, we'll give it a go. Anyway, you've got a trimmer here, which is a 1K trimmer. The 68 ohm resistors, so that makes it 34 ohms. To get this down that little bit more, there should be about 100 ohms or so, just around 100 ohm point. So it's about 1/10 of the value of this pot. So hopefully it's okay. I was going to hold this one in place with my finger to try and get it bedded onto the board properly. Okay, that should be right through. I've mentioned this in previous videos, I'll mention it again now. Whenever you're cutting the leads off, always put your finger over them, or if you can, try and grab them. Because if they go flicking off, they go anywhere. You can go into bits of test gear, through the slots and cooling vents and all sorts of stuff. So always make sure you know where they go. Now in theory, that's actually all it needs to work. But I'm going to put these other parts in as well, put some capacitors on the board. I really should have made this surface mount, it would have been far better I think. These are purely there to help any noise, to try and reduce any potential noise on the rails and stuff like that, to try and give better results. I mean, that's the hope anyway. These footprints aren't quite right, so I'm just going to sort of put these parts in kind of bodged in, I suppose. But these are 100 nanofarad caps. I could have used 10 nanofarad, it would have fitted a bit better. 100 nanofarad is quite a common value to use for things to give you a chance to do decoupling and reduce noise. So they're just there for that. I mean, it may not even need them. I designed it in, I thought, right, let's put them in. You know, it can't hurt. That's those. And also got a 100 microfarad cap here, 35 volt in this case. And that is going to go here. This is for the main power supply to help smooth that out as well. Bit of a bulk cap. May not even need that, but it depends on your power supply and how good it is, how good your cabling is, that kind of stuff. So there's no harm in having it, and it's only beneficial to solder these on. I'm soldering at 350 degrees. I tend to like to use quite a high temperature. I use a lot of heat when I'm soldering. If you're starting out and doing new electronic stuff, you're not really done much, I'd say use a lower temperature. But what can happen is you actually end up cooking things because you're sitting there with the heat on the board so long, it cooks it. And it can cause like this, the traces to lift off the board and all sorts of stuff if you're not careful. So I tend to use a high heat for a shorter time. Now when doing double-sided board like this, you've got to get the heat through the board. Especially when I'm doing like this, when I'm doing a ground plane. This board is ground plane both sides. So it's got a lot of effort to get through, right through the board. So it takes quite a bit for that heat to get right through the board and actually heat up both ground planes at the same time to allow me to actually get solder to flow across both sides of the board. When it's not a ground plane like this one, it doesn't take as much time, but it does still need to flow through the board. And flux is beneficial. I use it if I need to. In this case, I don't think I need to. So in theory, that's basically built. Obviously, I've got to put wires on it yet. Let's clean up all the residue on the back here, a bit of IPA, give us a clean, and then we're done. Well, kind of. We'll test it and see if it actually works. Right, let's try this out. I've got my Fluke 175 here. I've got it set on the 10 amp range in case something goes horribly wrong. I don't have a 400 milliamp fuse, but I can check that afterwards. I've soldered wires on here so we can actually hook up to these. So let's stick those on there, that'll be the current ranges. Right, I've just preset my power supply to be 4 volts at 200 milliamps current limit. So we'll hook this in. So at least it should limit the current if something goes horribly wrong. And 4 volts should be enough to make the board work. Let's do amps, DC. Right, let's turn the power on, see what happens. That's maxing out 200 milliamps, and we've got 200 milliamps going through here. Okay, and it could be this trimmer here is turned all the way down one end, which is meaning it's not doing the 25 ohm resistance, which is what I want to need. Let's wind it all the way one way, and we'll see what happens. It's clicking, so that's probably all the way. Let's try this again. No, all the way the other way. So it's a 25 turn pot, so it should be fairly decent. Assuming of course this works, it may not even work. I may have got it completely wrong. And we're still maxing out 200 milliamps. Have I stuffed up the design? Have I made a mistake? I may have done. Oh dear. So I've run the current up on the power supply and I've disconnected the current from here, and I'm getting 50 milliamps idle current, which seems reasonable. That's alright, I suppose. So when it's not actually trying to drive any current, it's okay. So I've actually put the voltage back down to 6 volts. I did the 4 volts again. Try this again. There we go. So that's doing 450 milliamps. Not quite the target I was looking for. Let me see if I can adjust this at all. So as I turn this clockwise, that is winding up the current. I can actually increase it. Turn it back on again. So it's doing 450 right now. I'll wind it up. Takes quite a few turns, but the current is actually increasing. See that? That's not what we want. So interestingly, I mean, it is working, but it's completely wrong. What have I got wrong here? Right, so I've adjusted now the resistance to be 25 ohms exactly, right? So 25 ohms is what we're supposed to have. I've done that trimming, so that shouldn't need to be changed now. So now I just need to figure out why it's doing too much current. Now what comes to mind is that TL431 can only pull down so much current, and it sort of sinks it down, and that's how it regulates. It's a bit like a Zener diode. It's basically adjustable to Zener diode. So either that TL431 is fake because I've got it from China, or the resistor, which is providing the voltage and the current to turn on this transistor here, because this is strapped across that transistor, that could be too low a value, so it's drawing too much current through that. So I might change that resistor there to be a bigger value, and we'll try it again.
One eternity later.
So after a bit of a period of troubleshooting there and figuring out what the hell's going on, why it didn't work, when it should have worked and everything told me it should have worked, I could not figure out why it did not work. Nothing made any sense. I was stuck on a breadboard, which is what I should have probably done in the first place. And I did some testing on here, just trying to figure out what the hell's going on. It didn't work in the breadboard either. It's like, well, why not? Maybe there's a pinout problem. So I actually got the BD139, even though I know that's the right pinout. Swapped it around, reversed it. No, that didn't fix it. Okay, put it back in. Did the same thing with the TL431, and suddenly it started working. When I fit it in backwards like this, the damn thing works. And I'm going to prove it. There you go, I've got it set to 3.5 volts, which is like the bottom end of the voltage cut out. It's working. 4.5, 5.5, 10 volts. Still perfect, fine. It daddy works. So now with that problem figured out, let's actually set this thing up properly and calibrate the current in a milliamp range. Which is why I put the trim on here. Because you have to allow for like voltage drop and current diversion through the transistor and stuff like that as well. Just slightly more, come on. There we go. Too much. How precise do you want it to be? Yeah, it's close enough. Oh, it's working. And that's at 3.5 volts, 4.5. They shifted very slightly then. So 3.5 is right at the very bottom end, I think, of where it's going to work. 3.4, 3.3, 3.2 is dropping off. 3.3 is right at the bottom end, and that's kind of what I wanted. I wanted to design it for that sort of level. If I put in a smaller resistor here, lower value, it's like 68 ohms right now, that is based on theoretical 4 volts. So my theory is correct at least. What I'd planned to do was actually run this thing off a 18650 cell, which is 4 volts ish when it's fully charged. 4.2 fully charged down to 3 volts, 3.1 volts minimum. So it's not quite the full charge rate of a battery. So I might look at adjusting that very slightly to allow for that. Maybe make it a very slightly lower resistance. If I can get that to work nicely across the whole range, that'd be good. So let's just give us a bit more of a tweak. I've gone a bit too far with it. Still really touchy. So this pot is, so it's a 1K pot, which I'm not happy with. I chose 1K because I didn't quite know what I was going to be dealing with. I thought, well, I can always change it later on, because if it doesn't quite work right, I can just change it. I think I need about 200 ohm pot or 250 ohm or something like that. That'll then give me about mid-range, mid-scale on it, which give me much more precision when I'm trying to adjust it. Yeah, I'm fairly happy with that. I mean, it's working. Transistor is barely warm. That's handling it just fine. Even without being bolted to the circuit board, it's just sitting in like that, so that seems fine. Resistors, nothing really appreciable there. Power supply resistor, which is powering everything basically, nothing appreciable there. Yeah, it's working. Excellent. Now there is going to be a second part to this. This is just the first stage of a project, something I want to make. And obviously this is the first thing I had to get working was this bit, which should have been easy. If this part wasn't footprint backwards, it would have been easy. So what I'm actually wondering is, this TL431, because I got this from AliExpress, maybe it's a different variant of it, and it's got a different pinout compared to what it would normally be. So it could be the variant I've got here is not the right one. Anyway, at least I figured it out. It works. What a palaver that was. Anyway, thanks a lot PCBWay for supplying the board for me at no cost. I may make these open source and make this available. In fact, I think I will. I'm going to make this open source, and that'll be available on PCBWay's website as a project. I will create a link for that down below once I've got that done. I think I'll do this. Now I've got a lot of complexity on this board which may not even need to be here. Got these ceramic caps here. They probably don't need to be there, but there's no harm in being there. It's reduced noise and stuff on the actual feedback and everything. Got a smoothing cap there for the power supply. Again, may not even be needed. I mean, if you're running for a battery, that's probably completely irrelevant, really. Probably doesn't really need it. It just helps smooth out this. If you've got any like bad connections on these current probes or something like this, because it is passing the power through there, maybe affecting the main rail, which is affecting this board. So I think having a little bit of smoothing cap on there is probably a good thing. I mean, it works now. I've got that part right around. I think I should buy some more of these from somewhere else, from a different source, and see if they end up being the correct way around. I think that's the thing to do. Now, another thing is these voltage references have tolerances on them. There's different grades of them. I think the basic one's like 2% accuracy or something like that, and you can get higher accuracy versions. So let's actually measure the voltage on it and see what we're actually getting. Yeah, got it set up over here. Let's probe on. Yeah, 2.489. So that is very slightly lower than the 2.5 volts I was expecting at that point to get the 100 milliamp range. That's okay. That's ballpark. I'm expecting some tolerance. That's why I put a trimmer on here. Excellent.